Assalamu alaikum students. I'm your math teacher from IYS school. Hope you all good and safe at home. Hope you all good and safe at home. Before starting the lecture, I'll give you some instructions. Hope you all understand and follow these instructions very carefully. Listen the whole lecture carefully. Don't raise your hand during lesson. Ask questions at the end of the lesson. Use hands-free if you are using mobile and headphones for computer use. Feed your ID and a password properly with your name and class. Take care of time for attending the class. Home tasks should be done in your fair copy of the subject. If there is any disconnectivity during the lecture, you just try to join again within 5 to 10 minutes. Don't turn on your videos during lesson. If you have any question related to the teaching or a topic, you may ask in the chat box after the lecture is end. Hope you all understand and follow these instructions. So, shall we start our lesson or a teaching? If every student can hear my voice, say yes in chat box. Students, can you hear my voice? Okay. So, now we start our today's teaching. Firstly, we we, uh, we read the chapter number 3 from your book, lowest common multiple, which is in today's topic we just learned at page number 26 to 28. And in today's teaching we cover exercise 3.3, which is from your book exercise page number 28. So here's the topic of the day. Listen carefully. Here's the topic of the day. In today's teaching, we just discuss about the different methods to find the least common multiple or the LCM. Okay. The first method is factor or a prime factor method. And the second one is division method. Before starting all these topics, I'll just give the review about the topics which we studied in previous teaching. So, in previous teaching, we just discussed about the common multiple, lowest common multiple, and so on things. So, what is common multiple? If you have to find the common multiples of any number of if you have to find the common multiples between any two numbers, any numbers. So here you see that we also discussed this example in previous teaching. So, if you want to find the common multiples of any number, firstly you just list out the multiples of that number. So here you see that firstly we just list out the multiples of 4. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. After the list out the multiples of the numbers which you have to find, then you have to find the common between these multiples. So here you see that here is the number highlighted, which is 12, 24, and 36 in the multiples of 4, and the same number is also highlighted in the multiples of 6. Here you see that the number of 12 is also highlighted, 24 and 36. So 12 and uh, 12 is common between the multiples of 4 and 6 both. Similarly, 24 is also the common multiple between 4 and 6. Similarly, 36 is also the common multiple of 4 and 6. So, in this question, you just find out the common multiples of 4 and 6. Here is no need or here is no restriction that how many multiples you have to find. So, if you find list out any 4 to 5, then it's okay. So, in your book, they just list out only 3. So, here you see that the common multiples between 4 and 6 is 12, 24, and 36. Hope you all understand. Again, now least common multiple. So, example number 1, which is also given in your book. find the least common multiple of 8 and 12, and uh, for the name least common multiple we just use the shortest form, which is called the LCM. Okay, L stands for least, C stands for common, and M stands for multiple. So before finding the least common multiple, we just list we just find out the common multiple. Okay, firstly we just find out the common multiple, then we find out the least common multiple. So in this slide, what can we do for finding the common multiples? Firstly we just list out the multiples of that number. So in this slide, firstly we just find the common multiple, so we just list out the common multiples of 8 and 12 firstly. So the multiple of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, and so on. Similarly, the multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96, and so on. Now we just firstly find out the common multiples between 8 and 12. So here you see that the first common multiple is 24, which is present in both the multiples of 8 and 12. Now second, here the second multiple is not highlighted, but I am giving you, but I told you, here you see that the number 48, and also you see that the number 48 also present in the multiple of 12. So the number 48 is also the common multiples between 8 and 12. So next multiple is, here you see that the multiple 72, 72 is present over here, and also present in the multiple of 12. Yes, so 72 is also the common multiples of 8 and 12. So first you just list out the common multiples of 8 and 12. So you just list out the multiples of common multiples of 8 and 12, which is 24, 48, and 72, and so on. Then you have to find the least common multiple. What's the meaning of least common multiple? The smallest multiples between all these multiples, all these common multiples. So here you see that 24 is less than 48, 24 is also less than 72. So here you see that the number 24 is smaller than all both of these numbers. That's why we pick 24 as the least common multiple of 8 and 12. Hope you all understand this method very clearly. Okay, students, now we just discuss about today's topic. So we discuss about, we have to find the LCM. If we have to find the LCM, we have two methods. The first one is factor method, and the other one is, yes, the other one is division method. In factor method, you just firstly find out the factors of that number, that number which you have to find the LCM. So here the example which is given from your book, which is taken from your book exercise, sorry, page number, yes, page number 26. Okay, students, open your book and see these examples in your book also and in your screen. Yes, in this example, what you have to find the LCM, least common multiple of 24 and the 36 by using factor method. Here they couldn't explain the whole thing, but you have to find the least common multiple of 26 and 24 and 36 by using factor method. So in factor method, firstly you just list out the factors of that number. So here you see that we just list out the factors of 24. Firstly, 24, what's the factor of 24 is 2 into 2 into 2 into 3. How? Because 2 into 2, 4, 4 into 2, 8, and 8 into 3, 24. Yes. So, what's the factors of 36? The factor of 36 is 2, 2, 3, 3. How? 2 to the 4, 4 to the 12, and 12 to the 36. Okay? So, here the factor 36 is the pair. After list out the factors of that number, then you have to find out the least common multiple by using factor method. So in this method, you firstly find out the common between them. So here you see that 2 is common between both 24 and 36, the first pair. Then you appear first pair as it is. The whole pair consider as only 1. So both the pair 2 into 2 we considered is only 1 2 because of the pair. So that's why we just write it over here only 2. Okay. Now you see that there is another pair. We just put another 2. Okay. Then you see that there is another pair of 3. Then you list out over 3. Here you have 3 pairs, 2 pairs of 2, 2 and a single pair of 3. Then you have to see that there is the number 2 and 3 is also here. In the LCM, firstly you just list out the common factor. You see that there is a common factor. For this common factor you just write only 2. For this common factor you also write this 2. But if you don't have to find, if you don't have any pair of this number, then you just put it same to same. So for this pair you just put only 1 2. For this pair you put another 2, and here is no another pair of 2, then we put 2 as it is. So here you see that we put another 2. Okay. For similar way, you see that there is only a single pair of 3. We just take 3 once. Then you see that there is no another pair with this 3. Then we take this 3 as it is. So here you see that there is 3 as it is. Now you just multiply all these factors. Then you find out the least common multiple. The answer is called the least common multiple. This method is called factor method or a prime factorization. Why we use the name prime factorization? Because you see that if the factors we have to find over here, all of these factors are the prime. 2 is also prime, this 2 is also prime, this 2 and 3 is also prime. So all these factors are the prime factors. That's why we say that this method is a prime factor method. Okay. Yes. So if you multiply all these, then the answer will become 72. So the LCM of 24 and 36 is 72. Hope you all understand. Here is another example for your better understanding. Yes. Find the LCM of 27, 35 and 48. Okay. Here you have to find the LCM between 3 numbers. So we just discussed previously here. Firstly, you just list out the factors of that number, and factors should be prime factors. Okay. So here you see that the number 27. So the prime factors of 27 is 3 into 3 into 3. All these three are the prime numbers or a prime factor. Then you list out the number, then you list out the factors or a prime factors of 35. So here you see that the 35, the prime factor of 35 is 5 into 7. Both the number 5 and 7 are the prime number. Then you have to list out the prime factor of 45. Here you see that the number 3 into 3 into 5. All these three numbers are the prime factors of 45. Okay. After list out the prime factor, you just find out the LCM. How? Firstly, you just find the greatest factor between all these three numbers. So here you see that for this product or for this prime factor of 27, the whole factor 3 into 3 into 3. Yes, the pair of 3 into 3 into 3 are the greatest prime factor. So we just take as it is. Or in similar way as we discussed over here, firstly you just pick the pairs, 2 pairs or 3 pairs. So here we have just only 2 digits or 2 numbers in which we have to find the LCM. But in this example, you have to find the LCM between these 3 numbers. Okay. So in your book, open your book, page number 27. In your book, there is explanation about how how can we pick the pairs of these if we have to find out the least common multiples between three numbers? So in your book they say that for the for the raw 27 you just pick out the pair 3 into 3 into 3, and from the pair of 35 you just pick the number 5, the least, and from the pair 45 you just pick out the, you see that for all these numbers you just see that 3 is also a pair over here because of these this product, and 5 is also a pair because of this product. Then you pick, then the 7 is also is the only remaining, then you put 7 as it is. But for your better understanding I'm giving you the another theory or a phenomena that if you find any of common between uh, any two numbers, then you pick it as a common factor. Okay, so here you see that the 3 is common in 27 and also in 45, sorry. So also in 45, so we just pick the number 3 and 3, make it a pair, and for the pair we just write only single 3. So here you see that we just only a pair of single 3. For the second pair you see that we have another pair between from 27 and 45, we see that there is a common between from 27 and 45. So you just pick, make a pair of this 3 3, then you take 3 as a pair. Now you see that there is just only a single 3, there is no another pair with this 3, then you take this 3 as it is. So here you see that for this pair you have one 3, for this pair you have another 3, for this 3 there is no pair, that's why you just take it as it is. So here 3 is as it is. Okay, so for the pair of or the finding of pair of 3, you just see that this 3 is also covered and these 3 is also covered. What's the remaining? The number, the pair of 35, 5 into 7, and the pair of 5 from 45. Then you see that the pair of 5, the number of 5 from here, and pair of 5 from 35 and a 45, you see a pair of 5. See, yes, you have a pair of 5, then you take the pair of 5 as a single 5, because if we have a pair then we take it as a single number. So you see that there is a pair, that's why we just take a single 5. Okay, then you see that all these 3's are covered and all these 3 and 5 are covered. This 5 is also covered, but 7 is remaining over here. If you see that there is no another pair with this 7, then you take this 7 as it is. So we took this 7 as it is over here. All the factors we want to find is list out over here. Then you just multiply all these prime factor, and the product is also called your answer or the LCMs between 27, 35 and 45 respectively. Okay, students, hope you all understand very clearly, hopefully. So for your better understanding, I'll just solve another question from your book, exercise 3.3, part A, question number 5. Exercise 3.3, part A, question number 5. In this question, you see that they have to find the LCM of the number 6, 10 and 15 by factor method. Okay, for which method? Factor method. So we discuss later, we discuss this in this slide and also in this slide. How can you find the LCM? By using factor method. Firstly, you just list out the prime factor of that number. So you just list out the prime factor of 6. Here you see that the prime factor of 6 is 2 into 3. Then you have to list out the prime factor of 10. So here the prime factor of 10 is 2 into 5. Both the number 2 and 5 are the prime factor. Then you have to list out the prime factor of 15. So the prime factor of 15 is 3 into 5. Here you see that every number has a pair. There is just only two. Here you see that the 2 is also a pair in the factor in 6, and 2 is also the factor of 10. So here you just pick as a pair. For the pair you just list out just only one. Okay. So the number 6 and 15 we have a pair 3. You see that the pair 3 is also a pair in 6, 3 is also a pair in 15. Then we take it as a pair 3 and write it over here just only a single 3 just because of the pair. Okay. Then you just list out or find out the remaining numbers. So here you see that 5 is also in the pair of 5, which is from the factor. 5 is the factor of 10 and 5 is also the factor of 15. So we take this 5 as a pair and take a single 5 just because of the pair is a pair in this method. So you see that we have all these three pairs. Then instead of writing all these numbers repeated again and again, we just write it as a pair. For this pair of 2, we just take just only a single 2. For this pair of 3, we take 3. And for this pair of 5, we just take a 5. Then you just have to multiply these numbers. 2 into 3, which is equal to 6, and 6 into 5, which is equal to 30. Yes, good. So, what's the LCM of 6, 10, and a 15 by factor method? The LCM of 6, 10, and 15 is, yes, 30. Good. You understand? Okay. Hope you all understand this method very clearly. Now we forward toward the second method, which is division method. Yes, division method. So, in the division method, here you see an example which is taken from your book, exercise, page number 27. Open your book, page number 27, and see the exercise, example 3. On your book, you see that there is this example 3, which is related to the division method. If you understand how can you find out the LCM by factor method, then you easily understand how can you find out the LCM by using division method. Okay, in the division method, you just find out the prime factor by division method. We discussed this method also in the chapter number 2, which is highest common divisor or division. So in this type of method we also discuss in this chapter. So if you understand this method, and you easily understand that method. So find the LCM of 24, 32, and 48 by using division method. Firstly, you just list out all these numbers, and then you find out the then you solve this by using division method. Take a prime factor of that number, and you have to take that number, and for this number you find out you cancel out, or you have to find all these three prime factors. So here you see that the number 2, 24 is also divisible by 2, 32 is also divisible by 2, and 48 is also divisible by 2. So if we divide 24 by 2, then the answer will become 12. Yes. If we divide 32 with 2, then the answer will 16. If we divide 48 with 2, then you see that the answer is 24. Yes, good. So after finding the first divisor, you have to continue this process until you have dividend or a remainder is 0, or if remainder is 1, or if you don't have a remainder is 1, then the remainder must be any prime number. Okay, so in this question you see that the remainder is 1, 2, and 1. here 1 is okay, but here is 2. Why we take 2 is as it is? Just because 2 is a prime number or a prime remainder. If we have a prime remainder, then we take it as a solution method. So here you see that after finding the first divisors of this, then you find out the another step. So you just check out if 12 is divisible by 2 or not. So you see, you know that 12 is also divisible by 2. 16 is also divisible by 2, and similarly 24 is divisible by 2, because here you divide 24 is already. So if we divide 12 by 2, then the answer is 6. If we divide 16 by 2, then the answer is 8. And if we divide 24 by 2, then the answer is 12. Similarly, you check out if all these three numbers is divisible by any single prime number. So you see that 6 is divisible by 2, 8 is also divisible by 2, and 12 is also divisible by 2. Yes, that's why we take this, and this divisor take it another. So if you see, if you find out the answer of 6 divided by 2, then the answer is 3. If you find out the answer of 8, yes, if you find out the answer of 8, then if you divide 8 by 2, then the answer is 24. If you divide 12 by 2, the answer is 6. Okay, now here you see that the number 3 is not divisible by 2, but the number 4 and 6 is divisible by 2. In this step, you have to understand, if you have a prime factor which is not divisible by any other divisor, then you just check out if any of two number is divisible by that divisor, then you have to solve this. But if you have just only a single divisor which is not divisible by this divisor, then you take it as it is. But here you see that the number 4 and 6 is divisible by 2. Yes, now 4 and 6 greater than one number, matlab, sorry, the number 4 and 6 both are divisible by 2. That's why we take 3 as it is. Then you have to find the divide find the answer of, if we divide 4 by 2, then the answer is 2. If we divide 6 by 2, then the answer is 3. Yes. After this step, you see that here all these three numbers are the prime factor. But you see that the number 3 is appeared two times over here, and we discuss uh, we discuss this. If you have a number or a divisor that divide any two of this number, then you firstly divide this number. So here you see that the number 3, here 3 is appeared two times, then you take 3 as a divisor. Yes, 3 as a divisor, and if you divide 3 by 3, then the answer is 1. If you divide 3 by 2, there is no answer. That's why we take 2 as it is. We don't divide we don't divide 2 by 3. We take 2 as it is. Okay, then you have to find out the answer. If we divide 3 divided by 3, then the answer is 1. Here you just stop your cycle of finding the divisors of these three number, or find the factors of these numbers, because here you see that the number, here you just have a number 2. If we take 2, then first 1 is also repeated again, and then so you have to find out. But here we just stop if we have a number which is if we have a number which is not divisible by any of factor, if you just have a single remainder. Okay, you see that here is a remainder 1 1 which we have to which we want, but 2 is also over here. We take 2 as a factor because 2 is a prime number. Okay, so what's the factors of the 24, 32, and a 48? The factors of 22, 30, 24, 32, 48 by using division method, the factor is 2 into 2 into 2 into 2 into 3, and we also take this 2 as a factor because we have this 2 as a reminder. So 2 is also taken as a factor. Okay, 4 times this 2, then this 3. You see that 4 times 2, 2, 2, then this 3, then the remainder of this 2, because it's a prime factor. You take this as 2 as it is. Then you just only multiply all these prime factors. Then the answer is a pair, or the product will become your answer. Okay. Yes, the answer or the factor you have to find is your answer. If you multiply all these factors, the factor is your answer. 2 into 2 into 2 into 2 into 3 into 2. Okay. Now we discuss another example related to this. Here you see another example. In this example, you have to find the LCM between 20, 30 and a 50. Similarly, you just find out any divisor that divide all these three numbers at a time. So here you see that 20 is also divisible by 2, 30 is also divisible by 2, 50 is also divisible by 2. Yes. So if we divide 20 by 2, then the answer is 10. If we divide 30 by 2, then the answer is 15. If we divide 50 by 2, then the answer is 25. After one division or one step, you have to check another time that find out any prime factor that divide all these three numbers. So here you see that if we take 2, then 2 divides 10 but not divisible, but not divide 12 and 25, 15 and 25, sorry. For similarly, if we take 3, then 3 just only divide 15, not 10 and 25. But the number 5 is divisible. The number 5 is divide 10, 15 and 25 at a time. Then you take 5 as a divisor. Yes, 5 as a divisor. 10 divided by 5, which is equal to 2. 15 divided by 5, which is equal to 3. And 25 divided by 5, which is equal to 5. Here you see that we have the reminder 2, 3 and 5. All these three numbers are the prime numbers. That's why we stop over here and take all these numbers. We list out over here as a divisor and a reminder. All these numbers we take it as a factor. Okay. So the number 2, 5, 2, 3 and 5. All these numbers are the LCMs. If we have to find, firstly you just find out the product of all these numbers, multiply all these numbers, then the product is called the LCM of 20, 30 and 50. Okay students, hope you all understand. Now we just forward toward the home task. Here you see a home task which you have to done in your fair copy. You have to complete exercise part A and B, all the questions from your book, page number 28. You have to do all these questions in your fair copy. All the questions of part A and all the questions of part B. Okay, students?